So in this video, we will talk about chemical equilibrium or chemical equilibrium. So, ang chemical equilibrium concept class is not only applicable in chemistry or even in just in analytical chemistry. This is applicable to all fields of chemistry and also to other disciplines as well, like physics, even biology. Okay? So, let's start with the equilibrium concept. So, many chemical reactions do not go to completion but instead attain a state of chemical equilibrium. It basically means that if I have a chemical reaction of A forming B, it means that, what you would expect is that nakay A and then mahurot siya to form B. But that does not happen kanang always. Okay? So there are so many reactions. In fact, I think there are more reactions that do not proceed or go to completion, but instead they attain a state of chemical equilibrium. So what happens is that you have A and then some of the A will be converted to B until such time nga it's like muhunong na ang pag-convert sa A into B. So, it's like no more change in the concentration of A and in the concentration of B. Okay? So, that is what we call as the state of chemical equilibrium. So, in chemical equilibrium class, it doesn't really mean na because the concentration of A and the concentration of B have remained constant, like wala na sila nag-change, it doesn't mean nga nihunong ang reaction. It seems like nga nihunong ang reaction, but actually, it is a dynamic, equilibrium is a dynamic process, okay? This is a dynamic process. So what's actually happening is that A converts to B, but then B is also converting to A. So what's actually happening is that the rate of formation of B is equal to the rate of formation of A, which is rate forward is equal to the rate reverse. Okay? And how do you know that the system has attained equilibrium? Okay, so let's take, for example, the conversion of N2O4 to NO2. Okay, so initially you only have N2O4. Okay, so this is the concentration at time 0, at T0, the concentration of N2O4 is right here. So, na siya value, di ba? And the concentration of NO2 is 0 at time equals 0. So, at the initial point, so, ang imong sud sa imuhang container is only N2O4. But then, as the reaction proceeds, the concentration of N2O4 decreases, di ba? Nagkaubos, naabot diri ang concentration, and the concentration of NO2 increases. So, naabot diri ang NO2, di ba? So, N2O4 is forming NO2, 2 moles of NO2. Okay? Until such time na ang concentration of N2O4 has come to a plateau, di ba? So, ni-flat na siya, which means nga ang concentration sa N2O4 kay ni constant na siya. And the concentration of NO2 as well kay ni constant na siya. That means that at this point, the N2O4 NO2 system, this reaction has reached chemical equilibrium. Meaning, in a state of chemical equilibrium, the concentration of the reactants and the products have remained constant with time. So, dili na siya mo change, bisag kapila pa ka magpaabot dira, bisag pila pa ka oras imong paaboton, that system has attained equilibrium. So, dili na mausab ang concentration sa N2O4 and NO2. Okay? So, here, this is just the graph of rate with time. So, as we know, ang rate is ang rate is just the change in the concentration of reactant. So for example, the change in concentration of N2O4 over the change in time. So it's just the slope of this. The slope of this one. Diba? Kay, diba, ang slope is, diba, y-axis ni, this is x-axis, ang time, diba? So, the slope is just y2 minus y1. So, change in concentration, change in y, over the change in x, or change in time. That's the rate. So, iyarang gi-plot ang rate versus the time. Okay? Now, if a system is can attain equilibrium, of course it has an equilibrium constant. So let us consider A plus B, this reaction A plus B to form C and D. So the small letter A, small letter B, small letter C, and small letter D are the stoichiometric coefficients. So A here and B are the reactants, and C and D are the products. Now, in this reaction, kining nga reaction, the equilibrium constant is the ratio of the equilibrium concentrations of products over the equilibrium concentrations of reactants. So that means concentration of products all over the concentration of reactants. And that is raised to their stoichiometric coefficients. So it's a concentration of C raised to the C, concentration of D raised to the D, concentration of A raised to A, and concentration of B raised to B. And that is the equilibrium constant. Okay? So, that means, for N2O4, atong reaction ganiha, for N2O4 to 2NO2, the equilibrium constant is NO2 squared over N2O4. Okay? Now, take note class nga whenever you write the equilibrium expression, equilibrium constant expression, this is what we call as the equilibrium constant expression. When you write this one, you should write this as how the equation is written. So, di ba, reversible man nga reaction, di ba? So, that means the reactant could become a product and the product could become a reactant, right? But in this case, in writing equilibrium constant expressions, you should follow how the equation is written. So, in this reaction, NO2 is the product. So, that is why NO2 should be in the products in the numerator. So, had this been written as 2NO2 to form N2O4, then the K for this one should have been N2O4 over NO2 squared. Okay? So, you should follow how the equation is written. Okay? Now, the value of the equilibrium constant expression Kc is constant for a given reaction at equilibrium at constant temperature. This is the law of mass action. What this basically means is that kini nga Kc, so this for N2O4 to form N2 to 2NO2, this equation, this has a constant gani, di gina siya mausab. Okay? So you can find these values at an appendix of a book baron. Okay? So it's written in the appendix of your module. Okay? So this means nga ang kining Kc, it's specific sad at a specific temperature. So for example, sa imong appendix sa imong book, you have the Kc value for this reaction, the Kc value for this reaction at 25 degrees Celsius. So, if different na sad siya nga temperature, lain na pud ang Kc nga value for this reaction. Okay? Now, also class, take note nga for this kanang expression, for the equilibrium constant expression, as you can see, ako dyan ang gibold ang equilibrium concentrations because many students kanang mistake this part. remember to use equilibrium concentrations when filling up this equation. Okay? So, equilibrium concentrations, which means nga, for example, here, the equilibrium, the expression for this one is NO2 squared over N2O4, right? Concentration. So, what this means is that you should take the equilibrium concentration. Ika-fill up ni mo ani, ika-substitute ni mo sa concentration. So, dili ka mo gamit sa initial concentration, okay? So, many students kay masayop ani. So, let me remind you nga, for example, in the case of N2O4 to 2NO2, initially, you have 2 molar of N2O4 and 0 molar of NO2, diba? At time equals 0. So, that means you don't fill this up using these concentrations. You fill this up with the concentrations at this point. Kini nga concentrations, because these concentrations are the equilibrium concentrations. Okay? Because this is an equilibrium constant expression, you should fill this up with equilibrium concentrations. Okay? Now, equilibrium class is governed by a principle called the Chateliers Principle. Okay, so let's take a look at this chemical reaction. Okay, so arsenic acid, this one, arsenic acid plus the iodide ion can form in acidic medium, can form arsenous acid and triiodide ion. Okay? Now, in solution, only this triiodide ion has an orange-red color. These other things here, other participants here, are colorless. Which means nga, if kini nga reaction, naani sa solution, if kani nga reaction, naani siya sa solution, naani sa imong beaker baron, you will find this as orange-red. Diba? Kay colorless ang uban, but there is orange-red. Of course, you'll see nga orange-red ang nasa imong solution. Okay? And that orange-red is caused by the triiodide ion. So, we can monitor the reaction by observing just the color. Diba? The color inside the container. So, for example, we have 1 millimole of arsenic acid. So, we have 1 millimole. First, we only have this arsenic acid. And then, we added this with 3 millimole of potassium iodide. So, potassium iodide class, that will form potassium ion and iodide ion. So, this is where the iodide ion comes from. This is actually the potassium iodide, okay? So, this I minus here is actually from potassium iodide. So, when this arsenic acid and potassium iodide are mixed, the red color of the triiodide's ion appears almost immediately. So, when this is mixed, ditso, na red-orange na ang color or orange-red. Okay, so, orange-red ang color. Okay? Now, within a few seconds, ang pagka-orange-red ang intensity of the orange-red has become constant, which means ni constant na pod ang triiodide. Okay? Because this orange-red is caused by the triiodide, di ba? So, ni constant na ang intensity sa orange-red, that means ni constant na pod ang triiodide nga ion concentration in your solution. Now, natay laing solution, we have another solution with identical color intensity. So, same ka-intensity, ani nga solution, same intensity, which means that it also has the same triiodide concentration. And this was produced by a different method. So it was produced from arsenous acid. So arsenous kaniha kini arsenous nasa product side dere, and triiodide. So gimix ra ang triiodide ug ang arsenous, they obtained the same orange red nga color. However, initially ato pag first jud nila nga mix, aning arsenous ug ang triiodide ion, the orange red color was very intense until such time nga ang intensity ni pareho na siya sa ka-intense sa first nimo nga solution. Okay? So that means from a very intense color, ni-decrease ang iyang intensity, which means ni-decrease pod ang triiodide nga concentration until such time nga ni pareho siya ani. Di ba? So if we imagine that class, we can say nga na reach jud niya ang ni-equilibrate ni kini nga solution, kini pod ni-equilibrate pod siya. Kay niabot man gid siya sa time nga ni pareho ang ilahang intensity, di ba? Okay, so ultimately, di ba? As I've said, that the color of the two solutions is identical. So many other combinations of the four reactants can be used to yield solutions that are not distinguishable from the two just described. And that means that the reaction has reached chemical equilibrium. Okay? Now, chemical equilibrium is governed by Chateliers Principle. This principle states that the position of chemical equilibrium always shifts in a direction that tends to relieve the effect of an applied stress. Atong bisayon ha. If nakoy equation, if nakoy reaction nga ni-reach na siya og equilibrium such as this one, katong constant na ang ka-orange red, di ba? Kini ni-reach ang equilibrium katong ang iyahang pagka-orange red is constant na, di ba? Ni-reach na siya nga katong ang concentration kay constant na. Katong ang pagka-orange red niya is ni constant na, di ba? That is when we know nga na-reach na niya ang chemical equilibrium. Ang principle, ang Chateliers Principle, kay ang meaning niya class kay if gi-disturb nimo ang equilibrium in any way, basta kay ma-disturb lang ang equilibrium, this reaction or the equilibrium will shift para mabalik ang equilibrium. Ang initial nga equilibrium para mabalik to siya. So, the reaction will shift the equilibrium para ma-relieve to ang gi-apply nga disturbance. Okay? So, unsaon man, how do we disturb an equilibrium nga system? So unsaon man siya pag-disturb? So there are three ways. We have change in concentration, change in temperature, ug change in pressure. So let's examine each. So let's have change in concentration first. Okay, so consider we have A plus B to form C and D. So in general, di ba? We know in general nga in the left side are the reactants and on the right side are the products. So A and B here are the reactants and C and D are the products. And take note class day nga ang kining double-headed arrow is used to describe a reversible nga reaction. Okay? So there are so many reversible reactions. Kanang even if kanang we cannot see or we cannot see it with our naked eyes right away nga reversible ang reaction, but actually they can be reversible. For example, inside our body we have so many reversible reactions, but they would only take they would take years before nato makita nga reversible dito siya. But with the help of enzymes, kanang mas mupaspas na ang kato nga reaction, so mas makita na nato nga reversible day siya. Okay, so makita na nato within seconds nga reversible dito nga reaction compared sa without the enzyme. Okay nga, it would take years before pa nato makita nga reversible dito siya. So it's not right to conclude nga irreversible ang reaction just because you don't see nga na change kanang na changes ba, reversible nga change. Okay, so going back, so changing the concentration is one of the ways to disturb an equilibrium system. So remember A plus B to form C plus D. No, this reaction is already at equilibrium. Okay, assuming nga this reaction has already attained equilibrium. So one way to disturb this equilibrium is to change the concentration. Okay? So, unsa man ang first question is that unsa man nga concentration ang i-change. So, actually, ang concentration, because this is already at equilibrium state. So, ang ma-change jud nga concentration para ma-disturb ang equilibrium is the equilibrium concentration of either of these components, either A, B, C, D, either of those. So, you can alter the concentration of A by adding A, or you can alter the concentration of D by removing D. Okay? So, initially, we have A and B in the solution. Diba? Initially, naratay A and B. And then, ang A and B, they react. And then, they form C and D. Now, until such time, pareho atong sa N2O4 and O2 nga system, until such time nga, dili na mo change ang concentration sa A, B, C, and D. And that means you already have an equilibrium mixture of A, B, C, and D. Now, when we say equilibrium, it means that the rate of formation of C and D is equal to the rate of formation of A and B. Okay? Don't forget that it is a dynamic process. That means the reaction is still going on. It's just that the rate of the forward is equal to the rate of the reverse reaction. Okay? So, ang pag-form ni mog C ug D, nara po'y nag-form og A ug B. That's why wala na kay makita nga change sa concentration. Okay? Now, in an equilibrium state, we're here now. In an equilibrium state, the concentration of the reactants and products are not changing with time anymore. You already know that. Or, the concentration of each component in the solution are constant. So, it doesn't mean, again, that the reaction has stopped. It just means that the rate of the forward is equal to the rate of the reverse reaction. We say that the reaction is in a dynamic state. Okay? Now, remember that the solution is in equilibrium. What do you think would happen if we add more A to the solution? So, di ba? We have A plus B to form C plus D. Now, what do you think would happen if we add more A in the equilibrium, in the solution? So, naman ni sa usa ka beaker, di ba? For example, nani sa usa ka beaker. So, if nagpuno pa jud ko og kani nga A, og ang A, what do you think would happen? According to Chateliers Principle, a solution in equilibrium will shift to counteract the added stress or disturbance. Counteract, okay? Remember, counteract the added stress or disturbance. Now, by adding A, di ba? You're adding A. So, unsa man ang disturbance nga imong gibuhat? Equilibrium naman ni nga system. But then, gipunan pa jud nimo og A ang system. So, nidaghan na ang concentration sa A, di ba? So, that is the stress or the disturbance that you applied to this equilibrium system. So, what would the equilibrium do? According to Le Chatelier, it will counteract the disturbance man. So what will the equilibrium do? The equilibrium the equilibrium will shift so that it will consume the added A. Diba? Kay gipunan man og A, so dapat kuhaon jud niya ang napuno nga A. So how will the equilibrium how will the system retain the equilibrium? Diba? So, since gipunan man siya og A, it needs to consume A, so it needs to shift to the forward direction. Okay? It needs to shift to the right to form more C and D para ma-retain ang equilibrium system until such time nga mo constant na sad. Now, what do you think would happen if I add C? Okay, so again, na-form na balik ang equilibrium, di ba? Nibalik na equilibrium. And then I added C. What do you think would happen? So since nagpuno man ka og C, the equilibrium will shift to use up the added C. How does it use up the added C? It will shift to the left to form more of these reactants. Kay para magamit ang C nga gipuno. Okay? So, again, na-retain na po ang equilibrium. Nabalik na po ang equilibrium. Wa na po na change. Na-constant na po ang concentration sa A, B, C, D. What do you think would happen if gi-remove na ko ang D? So, akong gitangtang, gihinay-hinay og tangtang ang D. What do you think would happen? So, since gi-remove man nimo ang D, dapat i-counteract nimo, dapat mag-produce ka og D, di ba? That is how you counteract the removal of D, to produce more D. So, how do you produce more D? The reaction or the system, the equilibrium should shift to the right to form more D, di ba? So, that is how the equilibrium works. And that is governed by Chateliers Principle. And in fact, class, in the industry, this is really kanang ang application dira niha in the Haber process. Kanang Haber process is N2 plus H2. This is just the formation of ammonia. In the Haber process class, they actually apply Le Chatelier's principle, the concept of equilibrium, in order to gain more profit. So what they do is that, di ba, N2 plus H2, but since this is kanang industrial production of ammonia man eh, so they wanted to produce ammonia. So what they do is sa ilahang process, ang ilang gibuhat sa ilang planta is that they have some tube nga slowly mag-remove siya sa ammonia. So while nag-produce na siya, mo reach man yung equilibrium kay this is a reversible man siyang reaction. So while nag-produce siya og ammonia, magsige sad og remove og ammonia and isud siya sa container nga kanang container for purification na ba, for downstream processes, para magsige siya produce gyapon og ammonia, kay magsige man siya try og reach attain sa equilibrium system, di ba nya? Unsa man pag-attain kung gasige siya remove og ammonia? So what happens is that kanang moabot jud sa time nga gamay na lang kayo, halos mahurot na nimo ang N2 or ang H2. So that will be kanang very efficient for them, kay ang ilang yield mudako kay more products but kanang same ra nga initial nga reactants, di ba? And they want more of the products man. That's what they want man, because ang product ang industry is ammonia man ang ilahang gi-mass produce. Okay? So next, I hope you understand how. Okay, so there is a summary written on your module class. So next is the change in temperature. Now, another way to disturb the equilibrium is to change the temperature of the system. So, in In the lab, you can just immerse the solution, the equilibrium system, in hot water or a cold water bath. Okay, that's how you do that in the lab. Now, let's consider the reaction A plus B to C plus D. And let's assume that this reaction is exothermic. Exothermic meaning it produces heat. Exothermic meaning it produces heat. That is why you have heat here in the product side. Kaya ni-produce siya og heat. Diba? Kabantay mo from your previous lab experience nga when you dissolve something, kanang muinit ang bottle, diba? Muinit ang like the dissolution of H2, the dissolution of metal in HCl, di ba? Muinit ang tube. So that is actually what you call as an exothermic na reaction. So ni-produce siya og heat. That is why naka-feel ka nga niinit ang tube. Okay? So let's consider this reaction A plus B to form C plus D. And this is exothermic. So you assume nga ang product niya also has heat. Now, this reaction, assuming this reaction has attained equilibrium, this is an equilibrium system. Okay? Now, I will disturb the equilibrium by immersing this solution. So, naman ni sa beaker, no? Example, nani siya sa flask. And then, this flask, I immerse this in a hot water bath. So, I'm increasing the temperature of this system. So, the system is this whole thing, including the beaker, nga gisudlan. So, I am increasing the temperature of the system. What do you think would happen to the equilibrium? Gidisturb man ako ang equilibrium. This is already at equilibrium. And then, I disturb it. What do you think would happen? So, what happens, since the reaction is exothermic, increasing the temperature would be like adding more heat to the product side. Mo favor siya kung asa tunay more heat, di ba? Kay since nag-add man kog heat, it's like I'm adding more of this, di ba? I'm adding more of this. So, based on Chateliers Principle, it has to counteract the added disturbance. So, if I added more heat, the equilibrium should shift to use up the added heat, which is to shift to the right, to form A and B. Okay? Now, what if this is the equilibrium system and I immerse this in a cold water bath? If I immerse this in a cold water bath, it's like I'm also removing heat, diba? Now, since I'm removing heat, that means to counteract, based on Chateliers Principle, to counteract the removal of heat here in the system, the equilibrium should shift to form back the heat that was removed, diba? So, the equilibrium will shift to the forward direction to form more of the products. Okay? And so, the system could attain equilibrium again. How about for endothermic reaction? Okay, so now, in the case of an endothermic reaction, endothermic meaning it needs heat or absorbs heat, alright? It absorbs heat in a reaction. So, that is also during kanang sometimes in dissolution, I think it's calcium chloride, I think. When you dissolve it, mubugnaw ang imuhang beaker nga gisudlan. Okay? When you dissolve it in water. So, it's just like the heat, since endothermic man siya, the heat is just like appeal siya sa imuhang reactants, di ba? Kaya it absorbs heat man. So, just you look at it like that. And so, if you immerse this in hot water bath, kung kini, imo ning gi-immerse sa hot water bath, it's like you're adding heat in the reactant side. Diba? So, how do you counteract that disturbance, that added heat. You need to use up the added heat, di ba? And to use up the added heat, you need to shift the reaction forward to form more C and D. Okay? Now, what if we do it the other way? We immerse this in a cold water bath. So if we immerse this in a cold water bath, it's like we're removing heat. So we have to produce heat again by shifting the equilibrium back to form more of the reactants. Okay? I hope that's clear before we proceed to the change in pressure. Okay, now the third way to disturb an equilibrium system is to change the pressure of the system. Now, changing the pressure of an equilibrium system is just like changing the concentration. But the thing is, in changing the pressure, it would only affect gases. Kay, di ba, if like we have chalk, chalk is a solid, di ba? If we kanang applyan og pressure ang chalk, like ato i-push ang chalk, will it experience or ma-experience niya ang pressure? Yes, but did it affect the chalk? It did not, di ba? So, it's the same thing here. Pressure only affects gases because the pressure exerted by solids or liquids, including aqueous solutions, are negligible. So, important thing here is, of course, that's why you have to look at the state of the components in your system, like this one. Okay? So, as I've said, pressure also affects the equilibrium system. It could disturb an equilibrium system, especially only kung gaseous ang imuhang nakay gaseous nga components sa imong system. So, let's take for example again this reaction. However, ato rang gibali ha. Okay? Okay. So here we have 2 moles of NO2. Okay? 2 moles of NO2 producing 1 mole of N2O4. So, initially, we have an equilibrium mixture of this. So, sud sa system, example, mao na imong flask nga nag-contain sa NO2 o N2O4. If these are N2O4, so you have, example, 1 mole of N2O4 and 2 moles of NO2. If you have that, okay, that's your system. And then, na siya'y piston nga nag-push dire. Okay, so for example, na piston nga nag-push dire. Sorry. This is the piston. So, this is the cylindrical nga container, okay? So, this is still part of the container. And this is the piston, okay? So, ang kining piston, mo ni ang mu-push and mu-pull sa imong sa kining, mo ni ang area, ang volume nga gi-occupy sa NO2 o N2O4 at equilibrium, okay? So, kung i-disturb na to ang system by changing the pressure, so for example, we push the piston to decrease the volume of the container such that instead nga na siya, ato siyang gi-push ang piston nga maabot na dire, okay? So now we have that, di ba? We still have the same number of moles of reactants and products, but the volume decreased, di ba? So what do you think happened to the concentration? Di ba? I said, changing the pressure is just like changing the concentration. But the thing is, ang napiktuhan rani is ang gas. Now, since in our system, we only have gas. These are all gaseous, di ba? So, what happens? What happened? Okay, so, gi-decrease mo ang volume, di ba? What happened to the pressure? pag-decrease nimo sa volume. Okay, so remember that pressure and volume are inversely proportional. So, pag-increase na to sa pressure, ni-decrease ang volume. I mean, pag-decrease na to sa volume, ni-increase ang pressure. So, pag-increase na to sa pressure, there are now 2 moles of NO2 in a smaller volume. Diba? 2 moles of NO2 per like half baron nga liter na lang instead of 1 liter. So that means we are increasing the concentration. Diba? It's like we are increasing the concentration. Now, here's the catch. Pag-increase na to sa concentration, diba? Pag-decrease na to sa volume, no? Ni-increase ang pressure. So, it's like ni-increase ang concentration. Okay, so it's like ni-increase ang concentration. Diba? Now, unsa man ang napiktuhan ani? So, in this case class, if we increase, when we increase the pressure, ang napiktuhan is the component with the greater number of gaseous molecules. So, in this case, it's like we are adding more of NO2 compared to N2O4. So, we are still adding N2O4. Of course, I mean not adding, but we are still making the concentration of N2O4 higher. But we are making mas dako ang pag-increase nato sa concentration, mas ni-affect siya sa NO2 kay daghan man ang NO2 daan. We have 2 moles of NO2 compared sa N2O4. Diba? Kay mas ma-concentrated imong NO2 kay duha na gudaan ang NO2 compared sa imong N2O4. That means the reaction, I mean the equilibrium will shift kay mas daghan man imong NO2 nga na murag mas ni concentrated imong NO2, di ba? So that means the equilibrium will shift to produce more of N2O4. So in layman's term lang ba kanang tinamban nga style, if you put yourself in the shoes of this NO2 o in the place of this NO2 o N2O4 ba, gipiit ka og maayo. Okay, initially mao ni ang imong system, di ba? Initially mao ni siya. Now by pushing the piston, more gipiit ka og maayo, di ba? Gipiit ka og maayo. But of course, ganiha mas hayahay man to, di ba? Kay mas dako ilang lugar. But then gipiit silag maayo, di ba? So kay gipiit man silag maayo, of course di sila ganahan nga sa usa ka reaction makaproduce og duha ka buok. Dili sila ganahan ana kay musamot sila og kapiit, di ba? So of course they would want to produce katong usa ra ang ma-produce, which is N2O4, kay there is only 1 mole of N2O4 sa kada 2 moles of NO2, di ba? So that would be mo nang ma-attain nimo balik ang equilibrium. Now, let's do the other way. So from here, ang piston atong padakan. So from this, atong patasan maayo. So naa diri ang piston. So it's like that. Mao na ni ang 1 mole of N2O4 ug 2 moles of NO2. Now, dako na sad kay silag lugar, sobra na kahayahay. So tinamban kung if you think about it, the equilibrium would want to shift to produce more of 2NO2. Di ba? Kay para mubalik sila sa ilang equilibrium state, which is in ani kining normal nila nga state, like the equilibrium nila nga state. Di ba? Did you understand that, class? Okay, so mas mura lang siya mas libog, pero mas libog kay ang buhaton ang pag-apply is i-decrease ang volume, una pa niya i-relate pa nimo sa pressure niya, ang pressure i-relate pa nimo sa number of molecules, di ba? Pero if you think about it nga katong tinamban nga style in layman's term kay murag mas dali ra siya sabton kung asa mo shift ang equilibrium. So remember nga if imong i-increase ang pressure, mo shift jud siya sa equilibrium. If you increase the pressure such as this one, increasing the pressure, mo shift jud siya sa equilibrium kung asa mo produce og mas gamay nga number of molecules. Kung palugakan sa nimo, if you decrease the pressure such as this one, mo shift sa siya sa equilibrium to form more of the molecules nga nay higher number of, sa component nga nay higher number of molecules. So in this case, nay 2NO2. Okay? Okay. Now, let's look at the effect of a catalyst on an equilibrium system. Okay? So for example, we have the equilibrium system A that goes to B. Now, we know that a catalyst lowers the activation energy for a reaction. So for example, this is time here. So, okay? So initially, we have A, di ba? Initially, we have A. Okay, so we have A here. This one, A. And then, the reaction of A goes down, di ba? At such point nga mabot siya at an equilibrium concentration. In the same way, initially we have 0 B and then we increase siya until such time nga mabot equilibrium. Okay? So this is B and this is A. Now, we know that as I've said, ang catalyst mo lower siya sa activation energy for the reaction. Di ba? Mao man ni ang graph sa catalyst. So, for example, this is the reactant here, ang energy sa imong reactant. And then mao ni ang sa products. So, this is the reactant and this is the products here. Di ba? And this one is the activation energy. Para maabot na siya, di ba? Ang purpose sa catalyst is to lower the activation energy. So instead of that, kanang maari na siya dire, di ba? Para mas mupaspas ang reaction. So the effect of the catalyst is to speed up a reaction, di ba? Now, the thing is, the catalyst could speed up the forward reaction, but it also speeds up the reverse reaction. So aside from speeding up the forward, it also speeds up the reverse, which cancels its effect. So that is why in an equilibrium system, the effect of a catalyst does not have any effect. Okay? So remember a catalyst does not have an effect or could not affect an equilibrium system. It could not disturb an equilibrium system. It could increase the rate of the reaction, but it increases the rate of the forward and the rate of the reverse reaction. So, makancel ra gyapon ang iyang effect. Okay? So, the equilibrium cannot be disturbed by a catalyst. Alright?